to take a look at one more partial fraction decomposition problem. This one's a little more complicated. So when we start this one, 2x plus 1 over x squared plus 1 times x plus 3. You're going to notice in the denominator here we have this x squared plus 1. It's a little different than what we've dealt with before. It is irreducible. So when we do this one, we're going to have ax plus b in the numerator divided by x squared plus 1. And then we will have plus c over x plus 3. And now when we multiply, we'll get just the denominator on the left. We'll have this quantity ax plus b, and then all ax plus b is missing. Oh, I just realized I made a mistake up here. This is ax, this is x plus 3. Alright. All ax plus b is missing is the x plus 3 term. And then all c is missing is our x squared plus 1. And now we can't just rely on clever substitutions for this one, because we have that x squared plus 1, and there's nothing that ever makes that 0 without involving imaginary numbers. And I don't think we're ready for calculus with imaginary numbers. So we can make one smart choice, because we have the x plus 3 here. We can do x equals negative 3. And when we do that, we will get 2 times negative 3 plus 1 is equal, the ax plus b is going to go to 0. And then we will have c times negative 3 squared plus 1. So 3 squared is 9, plus 1 is 10. We'll have 10c on the right. And then 2 times 3 is negative 6, plus 1 is negative 5. When we divide by 10, we'll get c is negative 1/2. Alright, so since we can't make any clever choices for x that'll make c go away, and either one of a or b, what we can do instead is we can look at what these terms have in common. So if we look, our highest power of x is x squared. So we know we're going to have a cx squared. But if we look on the left side, we have the ax and then x here. And that, at some point, is going to give us an ax squared if we were to FOIL this out. So we know we're going to have some a plus c. And there's no x squared term on the left side of the equal sign. So we know they have to equal 0 when you compare them to each other. And then we will have b times 3. And we'll have c times 1. And now these terms don't have any x's on them. So we can actually compare that with the constant on the left side of the equation. So that's a 1 on the left side. And we have b times 3, so 3b. And we have 1 times c, so plus just c. And I think that might be everything we need to solve this, because we know what c is equal to. So we have a plus negative 1/2 is equal to 0. So we know a is going to be equal to 1/2. And then on the other side, we have 1 is equal to 3b, and then plus another negative 1/2. So when we add that 1/2 over to the other side, we'll have 3/2 is equal to 3b. And then we divide by 3. So 1/3 of 3/2 is 1/2. And that'll be equal to b. Now that we've solved all of that, we can go back to integrating. We can write out our integral of the integral of 1/2 x plus 1/2 all divided by x squared plus 1 dx plus the integral of negative 1/2. We'll just pull the negative 1/2 out front. Negative 1/2, the integral 1 over x plus 3 dx. So you'll notice, let me scroll down here real quick. On the left side, we have these two 1/2s up in the numerator. So we can factor out a 1/2, and we'll get 1/2 of the integral of x plus 1 divided by x squared plus 1 dx minus 1/2 the integral of 1 over x plus 3. All right, and now, in order to solve this x plus 1 over x squared plus 1, we need to break it into two separate integrals. We'll rewrite this one more time. Have 1/2 the integral of x over x squared plus 1 dx plus 1/2 the integral of 1 over x squared plus 1 dx minus 1/2 the integral of 1 over x plus 3 dx. In this very left term, the x over x squared plus 1, we still can't integrate outright, so we're going to have to do a u substitution. So in that equation, we will let u be equal to x squared plus 1. Then we'll get a du of 2x dx, which means dx will equal 1 over 2x du. And now we can substitute back into that one. We can pull the 1/2 out from our du that we just found. So this will be 1/4 of the integral of 1 over u. Because when we substitute back in our du, we would have x over x, and those would cancel. And now we can start integrating the next couple of terms. So we have 1/2 the integral of 1 over x squared plus 1. And that's just an arctangent. So we'll have 1/2 the arctangent of x, and then minus 1/2 of the ln of x plus 3, and we'll go ahead and put our plus c on the end. Now we got one more step to integrate this 1 over u and plug back in. So we'll have 1/4 the ln of u, but we know u is equal to x squared plus 1. So I'll go ahead and substitute that in. We'll have the ln of x squared plus 1 plus 1/2 the arctangent of x, and minus 1/2 the ln of x plus 3, and our plus c on the end. And that's how you do that.